Welcome to BSc Statistics students. In this class, I explain fitting of logistic curve by the method of three selected points. Of course, there are four methods fitting the logistic curve. Method of three selected points, Yule's method, Hotelling's method, method of successive approximation, in which by the method of three selected points, I explain first in this class. What is a logistic curve? First of all, the logistic curve is yt is equivalent to be k divided by 1 plus e power a plus bt. Of course, it is one of the growth curve. I have explained the growth curve. I am explaining the growth curves in which I have already explained modified exponential curve, Gompertz curve. This is another growth curve, logistic curve. Correct? So, in which if we consider the logistic curve in the form yt is equal to k by 1 plus e power a plus bt, we have to fit and calculate the or estimate or obtain the parameters a and b. So that is our objective. So in the method of three selected points, what we do? Already we have considered in the modified exponential curve. We have to consider three equidistant points. For example, t1, t2 and t3 are three particular points, time points, are three particular time points at which the values of the time series of the variables, generally we call the ordinates, three ordinates, that is the value of the variable of the time series y1, y2, y3. Let the values of the variable of the time series data at the time period t1 is y1, at time period t2 is y2, time period t3 is y3. So three time points we have considered, equidistant, which means the distance from t1 to t2 is equal to t2 to t3, the distance of t2 to t3. That is, I write here t2 minus t1, the difference is t3 minus t2. These are equal. That is another point you have to observe. I am considering this is equation 1. That is the original curve of the logistic curve. And thereafter I proceed that I consider at the time period t1, I write the value of y1 from the equation logistic curve. y1 is equal to k divided by 1 plus e power a plus b into t1, bt1. And similarly, y2 is equivalent to be at the time period t2, at the time point t2, k divided by 1 plus e power a plus b t2 at the time point t2. And similarly, at the time point t3, y3 is going to be obtained by k divided by 1 plus e power a plus b into t3. So these are the ordinates, are the values of the time series at the respective time points t1, t2, t3, which are y1, y2 and y3. You understand this? Now, I consider first of all y1. I consider y1. y1 is equal to k by 1 plus e power a plus b t1. So which implies if I take 1 plus e power a plus b t1 left hand side and y1 right hand side, so that 1 plus e power a plus b t1, b into t1 is equal to k by y1. So now I calculate, I take this one particular one to the right hand side, so that e power a plus b into t1 is equal to k by y1 minus 1. So now we have to calculate the parameters a and b. That is the reason why I am considering logarithms. Consider logarithms. So that log e power x, it is x. That is a plus b t1 is equal to log to the base e k by y1 minus 1. K by y1 minus 1. Is it clear? Right. That a plus b into t1 is equal to log to the base e k by y1 minus 1. So let you consider it is another equation. So these are the values. If you consider y1, y2, y3 is equation 2, then I consider this is equation 3. So equation 1 is logistic curve, equation 2 is ordinates y1, y2, y3 values. Equation 3 is a plus b into t1 is equal to log to the base e, log k by y1 minus 1 to the base e. Similarly, we can also obtain, we can write a plus b into t2 from y2. We can write is log to the base e k by y2 minus 1. Let you consider this is a result 4. Similarly, we can also write from y3 a plus b into t2, t3 is equivalent to be log to the base e k by y3 minus 1. So these are the three results we have obtained from y1, y2, y3 from the equation 2. From y1 we have obtained this a plus b t1 is equal to log e to the log k by y1 minus 1 to the base e, and similarly a plus b t2 is equal to log k by y2 minus 1 to the base e. Similarly a plus b t3 is equal to log k by y3 minus 1 to the base e. These are the values we have obtained. The three particular values we have obtained. Now what we have to do? Subtract these two, 4 and 3. By subtracting 4 and 3, what you will get? So we will see a plus b2 minus a plus bt1, a plus bt2 minus a plus bt1. So a will get cancelled. B into, if you take common b, by subtracting 4 and 3, b into, if you take common b into t2 minus t1. Is it clear? These are the equations. bt1, bt2 minus bt1, 4 minus 3. So therefore b into t2 minus t1. Right hand side, log. Log directly we can write, okay, log k by y2 minus 1 minus logarithm to the base e k by y1 minus 1 to the base e. So which means, which is nothing but is equivalent to be log a minus b, log a by log b, log a by b, I'm sorry, log a minus b, log a minus log b, log a by b, log k by y2 minus 1 divided by k by y1 minus 1. This is what the value here for b into t2 minus t1. Now you leave this one and let you consider this is another equation, another result. After subtracting 4 and 3, we get some 6. Right now, we have to subtract 5 and 4. That is the equation of T3 and equation involves T2. These two and y3, y2. Right? Like so therefore, again by subtracting a minus a will get cancelled. bt3 minus bt2, which is nothing but by subtracting 5 and 4, the equations, we can obtain b into t3 minus t2. We can also write similarly in the similar fashion. The log k by y3 minus 1 minus log k by y2 minus 1. Therefore, k by y2 minus 1. You see, these are the two. values. Log k by y3 minus 1, k by y2 minus 1. So we can write log a minus log b. So therefore, we get log to the base e k by y3 minus 1 divided by k by y2 minus 1. So these are the values here we have obtained, and this is another equation I'm specifying. So there are two equations we have obtained by subtracting 4 and 3 and 5 and 4. So therefore, b into t2 minus t1 is equal to, this is the result we have obtained, b into t3 minus t2, this is the result we have obtained. But one thing I specify here, t2 minus t1 is equal to t3 minus t2. That is what at first we have specified. The time periods, time points are equidistant. The same distance we have. Therefore, t2 minus t1 is equal to t3 minus t2. So therefore, these two values are equal. b into t2 minus t1 is equal to b into t3 minus t2. Therefore, these two are equal. Therefore, from 6 and 7, from these two equations, we can specify that log to the base e k by y3 minus y1 divided by k by y2 minus y1 is equivalent to be log to the base e k by y2 minus y1 divided by k by y1 minus 1, which implies these two are equal. Log a is equal to log b, therefore a is equal to b. So these two are equal. I write in the next page. So therefore, k by y3 minus 1 divided by k by y2 minus 1 is equal to k by y2 minus 1 divided by k by y1 minus 1, which implies a cross multiplication. K by y3 minus 1 into k by y1 minus 1 is equal to k by y2 minus 1 whole square. Right? So therefore, if you do this, just simplify just by taking the multiplication like, so then k minus y3 by divided by y3 multiplied by k minus y1 divided by y1 is equal to, this is k minus y2 divided by y2 whole square. So therefore, by again simplifying the values, k multiplied by k, it is k square minus ky1 minus ky3 plus y1 y3 divided by y1 y3 is equal to k square, I am squaring, k square plus y2 square minus 2k y2 divided by y2 square. So these are the values. Now again you have to multiply with y2 square here, cross multiplication, y1 y3. So which implies k square y2 square minus k y1 y2 square, right, and minus k y3 y2 square plus y1 y3 y2 square is equal to y1 y3, you have to multiply k square y1 y3 and plus y2 square y1 y3 minus 2k y1 y2 y3, right? So these are the terms which are obtained here now. So any term is going to be cancelled. I will see. You see here, here y2 square y1 y3, y2 square y1 y3. So it will get cancelled. The remaining terms we have k in all the terms. So therefore I am cancelling 1k, and so that this becomes, and so that now you see remaining values 1 2 3 4 5, right? So if you cancel k, and k y2 square minus y1 y2 square minus y3 y2 square is equal to k y1 y3, because it is a k square. I am cancelling k, remaining k, minus I have cancelled k, 2 into y1 y2 y3, right? Now I take, I have to calculate k. So I take the value of k left hand side, k into y2 square minus y1 y3. These are the two terms, k y2 square, k y1 y3. If you take left hand side, minus k y1 y3. If you take common k, y2 square minus y1 y3 is equal to the remaining terms. I take these two particular terms on right hand side, y1 y2 square plus y3 y2 square minus 2 y1 y2 y3. So it is equivalent to be, I do one more step, y2 square, if you take common, y1 plus y3 minus 2 y1 y2 y3. Therefore, which implies the k is equivalent to be y2 square into y1 plus y3 minus 2 y1 y2 y3 divided by y2 square minus y1 y3. So this is the term I am taking right hand side. So therefore y2 square minus y divided by y2 square minus y1 y3. So this is the value of k. This is what the value of k. The k was obtained from the three selected points y1 y2 y3. The values of ordinates of y1 y2 y3 at the 3 points t1 t2 t3. We will have k. K can be obtained by y2 square into y1 plus y3 minus 2 y1 y2 y3 divided by y2 square minus y1 y3. So this is what the value of k. Now we have to calculate the other two parameters a and b. The two parameters a and b, for which we have to consider one such equation. So I will write the equation here. This is let it be k is another equation which we consider, for example, the equation 8. I did not remember what is the order of the equation, right? But now I consider one such equation which gives b multiplied by, it is in the equation 6. Okay, b multiplied by, we have calculated previously, b multiplied by t2 minus t1 is equal to, it is a log to the base e k by y2 minus 1 divided by k by y1 minus 1. This is what we have considered, in which if you substitute the value of k, this is equation 6, in which if you substitute the value of k, that is here one k, here another particular k, if you substitute the value of k, you will get the value of b, that's all. So therefore b is equal to 1 by, I am taking t2 minus t1 right hand side, 1 by t2 minus t1 into log, if you simplify this, k minus y2 divided by y2 and divided by k minus y1 divided by y1. So I have taken LCM y1 here, y2 here. Okay, so that it is equivalent to be 1 by t2 minus t1 into log to the base e, it is k minus y2 multiplied by, I am taking y1 numerator, into y1 divided by k minus y1 into, I'm taking this y2 here, y2. So this is what the value. So this is the value of b. Is it clear? This is the value of b. The value of b is now, let it be, this is equation 9. The value of b is in the equation 9. What you have to do is, we have to substitute the value of k from equation 8. This is what equation 8. The value of k is this. This is value of k. You have to substitute this value of k here, and so that you can obtain the value of b. This is what b. b is equal to 1 by t2 minus t1 log to the base a k minus y2 into y1 divided by k minus y1 into y2. So this is value of b. Now we have to obtain a. So for this I consider one more equation. One more equation. So what is that equation? It is equation 3 actually. This is the value, we are going back. A plus bt1 is equal to log to the base e k by y1 minus 1. This is the equation 3, what I remember. So in which the equation 3 we are substituting the values of b and k now. Previously we have substituted the value of k. Now we have to substitute, already b was calculated, b is calculated, and k is already calculated. So k and b are already calculated. So therefore a is obtained by taking a is equal to log to the base e k by y1 minus 1 to the base e minus bt1. I am taking the right hand side, bt1. So simply I am leaving. This is what equation sum 10. Right. So equation 10 provides you the value of a. The value of a. What is a? Log k by y1 minus 1 to the base e minus b into t1. So the values of b and value of k, the value of b and value of k should be obtained from equation 8 and 9, in which you have a formula. You have formulas. You have to use the formula of b and k and then substitute the values here. You will get the value of a. So this is what the procedure of determining the parameters a, b and k. So these are the three values. These three values you have to obtain from the given data by considering three selected points. But three selected points and the value of the variables y1, y2, y3 of time series data. And so that we have to find out a, b, k. And with these values, we can obtain the best fit of the logistic curve in the method of three selected points. You understand? Thank you.